functions like this before, so it's fine if it was challenging. But you have f of x is equal to, is it negative 1317 plus 304 ln x. Last class, for the record, I had so much trouble saying that function out loud. I kept on missing the 304, saying like 713. It was a rough beginning, but I think I'm getting better now. So the key thing to realize here is this says the growth of outpatient surgeries as a percent of total surgeries. So the output is that. What is the input? Where x is the number of years since 1900. So part A says, what does the function predict for the percent of outpatient surgeries in 1998? So how do you do that one? You plug in 98. So f of 98. Why 98, Jacob?
Because it's 98 years after 1900.
Correct. So what's the most common thing people did on A to do it wrong? They plugged in what instead?
8.
They plugged in, no, not 8. They plugged in 1998. Because they're like, oh, x is the time. But x is the years since 1900. You see this a lot on functions that have to do with modeling things over centuries. Because if you're really only interested in the 19th century, do you really care what the other part looks like? Not really. So what do? They just move the function. So what do you need in order to get a decimal on this? Can you do this by hand?
No.
What do you need to use? Your calculator. Exactly right. So do this on your calculator right now. Don't say it. And then you just hit enter. Oh, look. So raise your hand if you got that right there in front of me. You got that? Good. It's really important that you can type these things into your calculator. So you plugged in 1998, and what did you get out? 76.83. The next question says, what year will it be when the output is 50%? So we plugged in x, and we got an output. So we're trying to solve for x when the output is 50 for part B. So what equation are we trying to solve for B? Can anybody tell me what equation? 50, exactly, and highlighter would be a terrible choice. 50 equals negative 1317 plus 304, not 98, right, of x, right? So what are we're solving for x. If we want to solve for x, can someone give me the first little thing I should do first? What's the first thing? Yes, Calvin. Correct. So you end up with 1,367 equals 304 ln x. Can someone give me the next simple step? What should I do? I want to isolate x. Give me an easy thing to do, Alyssa. Correct. Thank you, Deb, for figuring it out. Yep. 1,367 over 304 equals ln x. What form is that in right there? What form is this? Is that log form or exponential form? This is log form. So what form could we put it in? Yes. What is ln? ln is what? Log base e. It's log base 10. Sorry, log base e. I listen to too many things at once sometimes. ln is just shorthand. It means log base e. So if that's in log form, can someone tell me what that is in exponential form? Can someone raise their hand and tell me what it is? Oracle, what is it? E to the. Nope.
Or e to the 130.
Yeah, 1,300 over equals. Hey, and is that something you can plug into your calculator? Do that for me right now.
You can't use 10. Are they like sort of interchangeable?
Not in this case. When it's ln, ln is log base e. Sometimes you can use one or the other, but in this case, it's already there. You can't just switch it out.
Got it.
What I mean by that, I'll get to it later, but do this right now. Do you have your calculator? Where's your surface? Okay, we're going to address this here. Can someone tell me what it is? Alyssa, what'd you get? Can someone tell me what this represents? That's time, but that's the, what is that? That's the, this is 1989 right here. Because it's years since what? Exactly. It's a little bit beyond 1989, but you could round it to 1990. Or I would accept 89 or 90, honest. That's totally fine. So does that make sense, everybody, what we did there? We just solved it in reverse. We got it into log form. What was the key thing here? What's the coefficient in front of log right here? Yes, there is. It's 1. When it's 1, that's when we can do this conversion to, what form is this? Exponential form. Can you do that if there's a coefficient other than 1? No, you have to move it to the power. You have to move it.
How would you move it to
first? So it would be log base e of x squared is equal to y, right? So it would be e to the y is equal to, then you could convert it. You have to move the exponent first. Correct. So basically it's asking when x equals 5,000, f of x equals what? Who got 55? Was it 55 exactly?
55.0338.
0338. Yeah, it's pretty close. Okay. So then the next one it says, what percent at 75,000? So I could say, for example, what is it? How high do you need to be to make it 50%? Yeah. Oh, it did. Look at that. How's it? There we go. Thank you. That's important. I've had that happen before, and kids are like, Mr. Seamon. They tell me like 5 minutes later. I'm like, oh, I feel bad now. Okay, so solve this for me. How about this one? F of x is equal to 50. What does x equal? Do that for me. So you have to do a little bit of algebra first, right? What equation do you need to set up to solve? What equation do you need to set up? 50 equals, good.
86.3.
Yep.
ln x minus 680.
Right. So is this very similar to what we just did?
That's what I did. It said it was wrong.
Well,
And then you just
you can't do anything yet. You have to do a lot of conversion. I know. I got a lot of M's. I didn't disconnect the keyboard and put my arm down on it. And, bad things happen. Okay, 680, right? So then what do you add to both sides?
680.
So you get 730.
And then you divide it by 86.3.
Good. So you end up with ln x is equal to what?
8.4.
Yeah, you did 730 divided. You did that out. That's totally fine. So what is ln? What is ln?
E.
No.
730.
No. What is ln stand for?
Oh, log e.
No. No.
Log base E.
Log base e. Log base e. So again, if I ask you what is ln, you say it's log base e. So now that that's in log form with a coefficient of 1, what can we convert it to?
Oh, exponential.
So it's e to the
730 over 86.3.
equals.
X.
Yeah. So you just do that on your calculator right there.
4580.
What'd you get?
4580.
Can you set 4, 5 what?
1,580.
Yep.
489737.
Yeah, something like that.
Yeah.
How many people agree? Oh yeah, I gotta turn up. What's 10% of 110?
11.
What's 11 plus 110? Oh look, is that a little bit more than we had before? After 2 years, what did we have before? 120. Why do we have $1 more? We have $1 more because we've done interest on the interest. Compound interest means you're taking interest on the interest and the principal. The principal is the initial amount of money. There's one and really only one big point we need to take away from today's class, which is the following. And it has to kind of do with a simple question. Let's say you had $100 in your account and you had 12% interest once. What's 12% of 100? Well, 12. What's 12 plus 100?
112.
So how much money do you have in your account at the end? $112. Let's say instead you took 1% interest 12 times. So instead of doing 12% interest once, Nate, I did 1% interest 12 times. Do you think you end up with the same amount of money, more money, or less money?
Same.
You kind of think like 12% interest once or 1% 12, you think it's going to be the same, right? It's actually a little bit more because you're taking interest on your interest a little bit more often. So this is the big takeaway from today's class. The big takeaway from today's class is the more, this is important, try to stop twitching for like 2 seconds, the more you compound, the more money you make. So what do you make more, 12% once or 1% 12 times? 1% 12 times. So, for example, the reason I said 12 times, how many months are there in a year? 12. So, for example, that could be monthly interest 1% 12 times, right? I could say daily. What do you think you're going to make more on? If I chopped it up into 360 pieces or 12 pieces? 360 pieces. You will make more money. There is a really cool formula, and we don't need to understand where it comes from, but you need to understand how to use it. And it looks like this. How many people have seen this before? Has anybody seen this before?
Never.
Okay. This has to do with how much money you have in an account. What do you think A stands for? Account actually stands for amount. Correct. It's principal. That's very good. Yeah. So it's amount, and this is principal, which is the starting amount in the account. What do you think R is? It is the rate. It's the interest rate in decimal. Rate in decimal. Is it really important that it's in decimal? Yeah. If I wrote 3 instead of 0.03, what is 3 in percent? That's 300, right? So sometimes you're going to do these problems and you're going to do a reality check. It's going to be like, Bobby puts $10 into his bank account every day for a year. How much money does he have at the end of the year? $3 billion. You're like, probably did the rate wrong. Probably. Or you're like, man, I want to go to that bank. What do you think T represents? Time in years. N is the really important one. Do you know what N stands for? And it's in 2 places.
Number of dollars.
Those are great guesses. Those are actually really good guesses. It's not. It's number of times compounded per year. So, for example, what is monthly?
12.
Exactly. So monthly equals 12. What's daily going to be? 365. Yeah. Actually, to be perfectly honest with you, what do they don't use 365 on daily sometimes. What do they use instead? Well, think about this. If you have to pick one number for a month, how many days in a month? Well, some of them have 31, right? But 28, but what do they pick? They pick 30. What's 12 times 30? 360. I'm just telling you, in some books you will see like daily interest as 360. Not important. I just want to tell you that. So here's the question.
Yeah, February is
28, exactly. And 29 sometimes. It gets all crazy. It's all messy. It does. My question to you is, how much money do you want to have in your bank account?
a lot.
Okay, just pick a number. I'm just asking you to pick a number. Okay, let's say you had $300 to start with. At what interest rate? What's a good interest rate? Let's do, say, 7%. That's super high.
That's very high.
For how many years?
5.
22.
5 years. Compounded. How often do you want it compounded?
12 times.
Compounded monthly.
12 times.
Guys, once I pick one, stop talking. So, what is this going to mean? So if I wanted to know what this equals, what's the principal? Someone tell me what the principal is. 300 times 1 plus what? 0.07 over 12 to the
12 times 5.
correct. So let's say, I have a question for you. Let's say I only changed this, instead of saying monthly, let's say I changed it to daily. I kept the same thing, but I did it daily. What would that be? 300 times 1 plus 360. Well, 365. You're absolutely right. That's fine. And I got to erase it. You guys can go in 1 second, so just chill. Hold on.
5 times 365.
Exactly. 365 times what? 5. Because it's 5 years. Now, here's the thing. Which one's bigger, monthly or daily? This is the thing I want you to understand. It doesn't get infinitely big. It's going to only go up by a little. You'll see that tonight when you do your homework.